Okay, now we're going to talk about derivatives of exponentials, like e to the x, or maybe 2 to the x, or maybe this exponent isn't just x. Maybe that exponent is 3x squared, or something like that. So here's the process. First of all, something to maybe just memorize. If y is equal to e to the x, the derivative of e to the x just also happens to be e to the x. But sometimes you're going to have like a 3x squared, so a would represent 3, n would represent 2, and this is the process. It's the original e to the ax to the n times the derivative So when you simplify this, each time you should be writing this. That's best practice. The 6x would come in front, and that's what it would look like. All right, so let's come over here. So dy dx, or you could say y prime, you write down the original. Oh, I left one off over here. Oh. All right, so you write the original, and then you multiply that by the derivative of the exponent function. So 2x, and then you bring the 2x in front. Just like that, all right? Let me go ahead and finish this one. So now we've got e to the e. So this one's a little bit more complex. So the original function, entire function is written. Now you have to take the derivative of that. Well, the derivative of this e to the exponent function is you rewrite that function and now multiply by the derivative of n, which would be 6x. So dy dx, the 6x is going to come out in front. Now notice we've got these two bases that are the same, so we can add those exponents together. So you only have to write e once, and this is e to the 3x squared. Then we're going to put plus 3x squared. And this right here is the final derivative. So now the similar, except for, well, and I should have showed you this with up here. You're also going to multiply it by the ln of e as part of the, so if it's e to the x, the derivative is e to the x times the natural log of the base. Well, ln of e, that base is e, so that just cancels to 1. So this is why the derivative of e to the x is e to the x, because the ln of e cancels to 1. So when we come over here to the base that is not e, you have to remember, so if you have 2, and then there's another function up here, the is 2 to that something, that original, times the natural log of base 2 times the derivative of whatever that function is in the exponent. So I'll show you an example. So write the original. Now we're going to multiply that by the natural log of base 2. And now we're going to multiply that by the derivative of that original exponent piece. And then we're going to bring the stuff in front. Now this is interesting. 10x can be rewritten as 5x times 2 to the first, and this is 2 to the 5x squared times the natural log of 2. Now look at those two bases. When you multiply it, you add the exponents. So this becomes 5x times 2 to the 5x squared plus 1 times ln of base 2. Okay, now we've got kind of another double thing going on. So dy dx, we write the original. But now, well, and by the way, before we go further, this base is 3, so the natural log of 3. Now we're going to start here. The derivative of this. Well, the derivative of this is you start with the original, and then the natural log of base 3 again, then times the derivative of 2x to the 5th, which is 10x to the 4th. And then let's see what we have here.